Hi, everyone, and welcome to the first session of IGCSE Math Preparation with Erfan. I'm going to be teaching you about numbers today. And as you all know, numbers and algebra are the most important topics in IGCSE Math exam as they include more than half of the syllabus. So without any further ado, let's start. Just like shapes, which you can classify them into different types of polygon, such as four-sided, you call it quadrilateral. If it's three-sided, you call it triangle, and etc. Numbers can be classified as well. So here we're going to talk about the most famous family of numbers. Let's start with whole numbers. So if you start counting with your fingers, you start from 1 all the way to 10, right? So we have our first family of numbers, which is whole numbers, and they start with they start with 1 and it keeps going. Then if you include 0 in this family, we have a bigger family of numbers which has basically one extra member, right, compared to whole numbers, and we call them natural numbers, and we use them with letter N, right? And something is missing here. For example, during the winter, the temperature in my hometown drops to negative 10 degrees Celsius. So we don't have any negative numbers here. So if I go ahead and include all the negative numbers from infinity, but it should be a whole numbers, guys. It should be integer, what we call it. So no decimal here. All right. So this is what I call integers, right? The positive and negative integers. And the notation is, we use the letter Z to show integers. And what else is missing here? Sometimes when you ask a kid how old they are, they come up with a very funny answer. They say, I'm 4.5 years old or 6.5, right? Which we don't have that here. So if you go ahead, those are fractional numbers, guys. Fraction is when you divide an integer by another integer, and the one in the denominator should not be 0, because that would make this fraction undefined, right? So we call those rational numbers, right? So if I include rational numbers, I have a bigger family, and the notation is Q, rational. So you know what rational number is now. Any number that can be written as a fraction, we call it rational. For example, 0.9 can be written as 9/10, right? And we're going to talk about how to do this conversion in the following topics, how you can write a decimal number into a fractional number, and how you can rewrite a fractional and convert it to a decimal. We will be talking about all of those. So I don't need to, because the fractional, when you include the rational numbers, there are a lot of them. So I can't really put all of them here. But if I want to use a number line, so if I use a number line which goes from negative infinity all the way to positive infinity, still there are some numbers missing. Rational numbers don't include all the numbers. Can you think of any number that is not rational? For example, pi, right? Maybe that's the first number that went through your mind. Pi, which is a very famous number, it cannot be written as a fraction. The reason is that it has the decimals or the digits after the decimal points, they don't really follow a certain pattern, right? There is no pattern into it, so therefore we call it irrational. There are other famous numbers in math, such as E, the Euler number. What else? These are the two that I can think of right now. But the irrational numbers, there are more, because for example, the square root of non-square numbers, square root of 2 or square root of 3, or even cube root of non-cube numbers. So basically cube root of 27 doesn't count, guys, because the answer is 3. So this is not irrational numbers. However, the cube root of 15, for example, this is an irrational number, because if you key in your calculator, again, there is no pattern there, and the basically the digits, they don't repeat themselves in a in an orderly fashion, and we cannot really guess the next one. So we're going to talk about the terminating and recurring decimals in details. However, where was I? Yeah, here we call these family irrational numbers. And if you include these numbers and add them up together with rational numbers, then we have the biggest family that we're going to deal with throughout the book here, which we call it real numbers, and the notation is the letter R. We have, guys, basically complex numbers or imaginary numbers, which you're going to learn in A level, and you don't have to be worried about that right now. So this is all about numbers. So let's talk about some other terminologies which you need to know before we get to some real stuff. The next thing I want to talk about is prime numbers. So this is something that you might have learned in lower secondary, but it is worth to mention it here as well. So prime numbers are those numbers that are only divisible by themselves and 1. For example, 7 can only be divided by itself, 7, and also 1. So 7 is a prime number. However, 8 is not, because it can be divided by 1, it can be divided by 2, it can be divided by 4, and it can be divided, of course, by itself. So that is not a prime number. So I think it's clear what a prime number is. I suggest you to go ahead and write all the prime numbers in order from 1 to 100. This is a good practice that I always ask my students to do. And remember, 2 is the only prime number which is even. So 2 is prime number. 1, guys, is not a prime number. That's another mistake that some students make. So the smallest prime number, which happens to be even, is 2, right? After that, you cannot find any prime number which is even. So all of them after 2, they are odd. So 3, if we go in order, the next one would be 5, right? 7, 11, 13, and it keeps going. Now, you all know what square number and cube number is, right? Square number is obtained when you multiply a number by itself, and cube number is obtained when you multiply a number by itself and again by itself. So basically, you do that twice. And again, I suggest you to memorize the square and the cube of the numbers from 1 to 10. So basically 1, we don't need to, we can skip 1 because 1 raised to the power of anything is 1. So 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I strongly suggest you to remember the basically the second power or the square of these numbers, and also the cube of them, meaning which 2 to the power of 3, 3 to the power of 3. So it's not really difficult if you memorize them. You're going to thank me later. It makes your calculation way faster, especially when we get to sequences. You can relate to the numbers in the terms in the sequence way better if you're familiar with these numbers. For example, when I show you number 125, the first thing that to go through your mind is that this number is a cube number. Then the next thing, which is obvious because of the last digit, that's it's divisible by 5, right? We're going to talk about divisibility as well, because if you go through past year paper question, there are some questions. It's very rare, but they still ask you that which one of the following numbers are divisible by 3, something like that. But right now, my concern is that you guys learn all these numbers, right? And later on, when we get to the indices and powers, I ask you to memorize the powers of 2 and 3 until 10. Again, that makes your life way easier. But anyway, this is your task to do. Let's move on to the next subtopic for this chapter, which is factors. So what do you know about factors? If I let's talk about number 18. If I ask you to list down the numbers that 18 is divisible by, so you say, okay, 18 is divisible by 1, or maybe I can ask it this way: list down all the numbers that can be divided exactly into 18. So that's another way of saying it. So 1, 2, 3, right? Because 18 divided by 3 is 6, and the remainder is 0. Then 4, no. 5, no. 6, yes. Then 9 as well. So we have already reached half, right? 9 is half of 18. So once you reach half, then there is no number between until the number itself, which is 18 in this case. So I hope I have listed all. Let me double check. 1, 2, 3, 6, 9, and 18. Yes. So these are called the factors of 18. But what I'm interested here is basically the prime factors, right? The prime factors in this case are 2 and 3. So if you do that for any number, you're going to find that there are some prime factors. Let me do that for 12 as well. We're going to get 1, 2. So make sure you put a comma between the numbers. And again, the question was to list all the factors. Then we get 3, 4, 6, and 12. So we have 4 here, but we don't have 9 like above. But the number of factors are same, right? 6 here, 6 up there. Now, again, as you can see, there are 2 of these factors, right, which happens to be prime factors. Now, why prime factor is very important? Because any number that you can think of, you can rewrite it in the product of their prime factors. What does that mean? For example, look at number 12. 12 can be rewritten as 4 times 3, or 4, we know that it's 2 to the power of 2 is a square number, and times 3. And as you can see, I just used prime factors. That's all, 2 and 3. Well, the index, of course, can be more than 1. It shouldn't be necessary 1. In this case, you can see the index here is 2, and the index for 3 is 1. Or you could have written it like this, 2 times 2 times 3, right? It's the same thing. But you're not allowed to use any number rather than a prime. Okay, I'm going to do that for 18 as well. 18 can be rewritten as 2 times 3 times 3. So this time the power of 3 is 2. So in short, you can write it as 2 times 3 to the power of 2, right? So why is this important? Because later on, when I introduce you to the highest common factor and lowest common multiple, we're gonna use this, right? We're gonna use this concept and we're gonna write the numbers first in the product of their prime factors, then we're gonna find the HCF or LCM, right? And now you might ask yourself, how am I supposed to do this? Well, for 12 and 18, it was relatively easy. However, if the number gets big, or for example, 72, how am I going to do this for 72? Do I need to list the factors first and then take out the prime ones, just like what I did here? Well, the answer is no, because that's a waste of time. Do not do that unless the question asks you to, okay? If they ask you specifically to rewrite the number in the product of its prime factors, so you don't need to bother yourself with the other factors. Just go ahead and find the prime ones. And how can you do that? Well, one easy way is to actually divide by the prime numbers in order. Of course, from the smallest first, which is 2. The smallest prime number that exists, it is 2. So what do I mean when I say start by dividing by the prime number? So let's say this is 72. I have it here. So draw a vertical line. You can do that next to it, either left or right, doesn't really matter. And then start dividing by prime numbers and start with the smallest. So the smallest prime number that exists is 2. And you write that here on the left. So on the right, you write the number itself. On the left, the smallest prime number, which can be divided exactly into 72. Well, in this case, we're lucky because 72 is an even number and it can be divided by 2. So if you divide 72 by 2, you get 36, and you write that here. Now, the next question you should ask yourself is that, is it also divisible by 2, or should I move on to the next prime number, which is 3? Right after 2, it comes 3, right? But the answer is yes, it is divisible by 2. And then you do that again. That gives us 18. 36 divided by 2 is 18. Then it seems I can divide it one more time further by 2. That gives me 9. I can divide it, well, it's not divisible by 2 any longer. I have to choose the next prime number that comes after 2. In this case, it's 3. Now, if let's say if it was not divisible by 3, you should move to the next one, which is 5, right? But it is divisible, so I'm gonna stick to 3. Sorry about the mess. So if I do that, I get a 3. You divide it by 3 one more time, you get a 1, right? So I have listed all the prime factors in 72. Now what I'm gonna do with that, you write 72 here, and 72 can be obtained by just multiplying these numbers on the left that you have obtained by this division. So basically we have 3 2s and 2 3s, right? Okay, and if you wanna use the indices, you can use the index 3, and here you can use the index 2, right? And don't rewrite it as 8 times 9. That's useless. This doesn't help us much, because as I told you earlier, we we're gonna use these two numbers and as well as their indices, right? So let's do one more time and with another number. Let's try maybe, I don't know, 28, right? So I can start with 2, fine. Then I get 14 divided by 2 one more time, I get 7. And 7 is a prime number already, right? So we have reached a prime number. The only prime number that I can use right now is 7 itself. So 28 can be rewritten as 2 times 2 times 7, or 2 to the power of 2 times 7. So you should practice that a lot, guys, because we want to talk about the highest common factor and LCM in the next slide. So I hope it is all right. Maybe you can do that for these numbers like 125 or 22 and 56 yourself, right? This one you should get 5 to the power of 3. This one you should get 2 times 11. And now the next topic, which is always a question, and this is the most frequently question that you can see that almost in every past year paper question, that is HCF, or highest common factor. Now, you know what factor means, you know what highest mean, and you know what common means as well. So we must be talking about more than two numbers, and we want to find out what is the highest common factor between those two numbers. So let's talk about 12 and 18, which we discussed in previous slide here, right? So if I ask you to list down all the factors, right? List down all the factors. Again, you start with 1. It's better if you do it in an ascending order from smallest to the largest. So we get these 6 numbers. For 18, we get these numbers. And these are all the factors of 12, and these are all the factors of 18. And if I ask you, what are the common factors, right? So we started with factors. Now let's move on to the common factors. You would circle these numbers. You say, okay, 2 and 3 and 6. These are the common factors. And if I ask you, okay, out of those common factors, which factors are the highest factors, right? That's the third step. You would circle out 6 only, right? And you would say the HCF of 12 and 18 is 6, right? Well, this method is correct. However, it's not really professional. And again, it is time consuming, especially if these two numbers are large. So there is another way. As a matter of fact, there are two other ways, but I'm going to teach you the one that requires the product of the prime numbers, the one that we did on previous slide. So let's talk about it here. And let me rewrite 12 and 18 in product of their prime factors. Here I get 2 to the power of 2 times 3. Here I get 2 times 3 to the power of 2. Now, in this method, if you want to find the HCF of two numbers, which you have already rewritten them in the product of their prime factors, you have to choose the common factors. And as you can see, 2 and 3 are common between 12 and 18. So we must have in our answer, I must have 2 and 3. And of course, do not forget the product, right? If there was another number, I should add it right here. But it must be common. Guys, it must be common. For example, if there is a 5 here, you do not include 5. You do not put it here, because 5 only belongs to this number, not 12, okay? So let me erase that because 5 is not a prime factor of 18. Okay, now what's the next step I should do? I should choose the power now because 2 is repeated and it's shown up in two places here and there. The index here is 1, here the index is 2. So for HCF, you choose the lowest index, which is this one, right? This is 1, this is 2. So you choose the lowest one and you put it there on the corresponding number. You do the same thing for 3 as well. As you can see, 3 has the power 1 here. The power here is 2. So I'm going to choose 1 and I put it here and the answer is 6, right? So this was easy. However, it takes a little bit of practice, especially this part, which you need to rewrite it in the product of its prime numbers. Let's talk about another two numbers. It could be 3 as well. In this bracket, they could give you 3 numbers, right? And maybe we can do that right here. Let's see. Let's examine the numbers 72 and then 24 and then maybe 36, these 3 numbers. So as a practice, I'm gonna do this method. However, I could do it mentally, but just as a recap, maybe we can do it here together quickly. 72, I have already done it. So let's start with 2. You divide it, you get 36. Guys, for this, you can use a calculator, but I suggest you right from the beginning, stop using the calculator for these unnecessary calculations. Believe me, it slows you down. It slows you down. The purpose of calculation is not to slow you down. It is there to help you with the calculation. So use your brain to do this mentally and you will thank me later. From now on, let's develop this habit, which is a very good habit, by the way. Um, at first, it must be difficult, but you're going to get there. Don't worry. So 36 divided by 2, 18 by 2, 9. Skip 2 because it's not divisible by 2 anymore. 3 is the next prime number. Divided by 3, you get 3, 3 one more time, that's 1. So 72 is 2 to the power of 3 times 3 to the power of 2. How about 24? 24 divided by 2. Guys, you can divide by 4 or 6, but that's not uh, our purpose here. Remember, I said everything here should be prime number, and you should start with smallest. If it's not divisible, you move on to the next one. So 2 is the smallest, and we get 12, hopefully. And then again, I can use 2. I can use 3 as well, but use 2 as much as you can. So as long as you can, it's better to say that way. So 2, you get 6. Again 2, you get 3. Now it's time to move to 3, which you get 1. So 24 is 2 to the power of 3 times 3. For 36, I start with 2. You get 18, 2, 9, 3, 3, 3, 1, right? So it's 2 to the power of 2 times 3 to the power of 2, right? Now, it's very obvious that 2 and 3 is shown up everywhere. So definitely the HCF of these 3 numbers, it's 2 raised to the power of something times 3 raised to the power of something, right? And we have to figure it out. What is that index? So I said, choose the lowest one, right? The index for 2 is here 2. Here is 3. Here is 3. So I choose the smallest one, which is 2. So instead of this question mark, I'm going to put 2, right? And for 3, same thing. This is 2. This is 1. This is 2. And I choose 1. And the answer is 12. right? 4 times 3, 12. Now, guys, there is another way that you can do it. Maybe in lower secondary, your teacher has taught you that way. But if you feel comfortable with that method, I suggest you to do it. So basically, that method is also used for LCM. So here is how it works for those of you have already learned it, or those of you who just want to know out of curiosity how it works. So we write all the three numbers here, and we're gonna look for a number that we can divide all of these by that. So in other words, the smallest number that can be divided exactly into all these three, and that is 2. And if you do that, then this guy is reduced to 36, this guy is reduced to 12, and this guy is reduced to 18. So we're gonna go ahead and see if we can do that again. Is there a small prime? It shouldn't necessarily be prime. Actually, when you use this method, it doesn't have to be prime, meaning which for the next one, I could have divided everything by 6 basically. Yeah, if you're using this method, guys, you don't need to stick to prime. So basically, any number that goes through your mind, I can think of 2, 4, or 6. The biggest that I can think of is 6 right now. So if you do that, here you get 12, here you get 4, sorry, here you get 4, and here you get 6. And then you're gonna think about another number that you can divide all these three by that, and that is 2, right? 3 is not possible. 2, right? And you get 6, 2, and 3. And there is no number that you can find and divide all these three by that, right? It doesn't exist. So you stop there and you multiply whatever number that you have here, all of them together. I have started with 6. You could have started with 4. Or just like what I did at the beginning, do you recall? I started with 2. If I have continued that, I ended up having 2, 2, and for the last row, I would definitely get a 3 if I have continued that. But it doesn't matter. Till here, when you multiply these factors, you get the HCF. However, if you continue this method, so here 6 times 2 is 12, but if you keep doing it, meaning which after here, of course, there is no common factor, but our goal is to make all these three 1 at the end, right? So if you do that, then, and if you include all the factors, then we have ourselves the LCM, something that we call the LCM, lowest common multiple. So this method is also common. I don't want to really get into the details because I haven't talked about LCM yet. So after this part, I didn't do it. But this is also a common way that some students find it easier. Maybe I teach you the LCM, and then we get back to this part and try to complete it. And this is a good and effective method that you can find HCF and LCM at the same time. Here as well, actually, we're gonna find the LCM from these numbers, guys. So this is also a very good method as well. So let me talk about LCM and we will get back to that example. So LCM, or lowest common multiple. So what is it really? This is the lowest common multiple. All right. So let me give you the examples like those two numbers, 12 and 18. And if I ask you this time, I'm not going to ask you to list down the factors. You have to list down the multiples. So what are the multiples of 12? The multiples of 12, of course, you start with 12 itself. 12 times 1 gives you 12. 12 times 2 gives you 24. 12 times 3, 36, right? The multiples of 12. So you multiply it by the whole numbers and see what it gets you. And then the next one, of course, would be 48, right? 60 and 72 and 84, right? And it keeps going, right? I think that's enough. If we do the same thing for 18, right? And I suggest you again to do it mentally. Don't use a calculator. It might be a bit time consuming at first, but this is a good practice anyway. 18 times 1 is 18. So basically the idea is that you need to list down the multiples of number 18, right? And if you do that, you get the next one would be 54, and the one after that is 72, and the one after that would be 90. Am I right? And it keeps going. So we listed down the multiples. That's the first step. And let's take out the common ones. So maybe I continue the list a few more numbers and we get few common multiples. How about that? This is 84. The next one would be 96. And after that would be 108, right? And it keeps going. And this one, of course, is 108. And after that, no need. So this is the common ones are 36. That's the common one. What else? 72 and 108. And it keeps going, right? These are the common ones, guys. And out of which, if I ask you to circle out the lowest, this is the third step, right? Of course, you would say 36. So 36 is the LCM of 12 and 18, right? The LCM of 12 and 18 is 36. The HCF, guys, if you remember, was 6, right? I hope you haven't forgotten that. Now, how are we this, because this is definitely time consuming, guys, especially if they give you 2 weird numbers or even 3. This is really time consuming, whether you use your mind to do the calculation mentally or use a calculator for that. Still, it's really tedious task to do. So let's go back to the method that I've taught you just now. You can rewrite 12 as 2 to the power of 2 times 3, okay, and 18 as 2 times 3 to the power of 2, right? So I hope you haven't forgotten how we got these two expressions. And here, unlike the HCF, we write all the factors, any factors that you see, not just common ones. Well, here we have only 2 and 3. Here we got 2 and 3. But let's say if there was a 5 here and there was not a 5 here, basically 5 was uncommon, right? Still, you have to include that. So that's what I mean by all the factors, common and non-common. So this is 2 times 3. And again, we have to choose an index for them. But this time we go with the highest, unlike the HCF, which we targeted the lowest. So 2, the index for 2 here is 2, here is 1. I'm going to choose 2 and I put it here. For 3, this is 1, this is 2, and I choose the highest, which is 2. And if you do the calculation here, you would see that the answer is 36, just like what we got up here, right? So this is quite an effective method and easy, I would say, especially if you practice this part, the rest would be easy. So let's talk about some other numbers, such as 15 and 36. So if you list all the multiples, that would be very difficult. For 15, the next one is 30, 45, 60, 75, 90. It keeps going. For 36, that would be 72, and then 108, right? And it keeps going. And then you have to circle the first common numbers or factors that, I'm sorry, multiple, not factors, that you reach. However, we're not going to do that, guys. We're not going to do that. I've taught you an easier way, which is go ahead and rewrite 15 as the product of its prime numbers. If you cannot do it mentally by now, it's okay. On a piece of paper, you can practice that. Even in the exam, it is all right to do this, guys. No issue there. So 15, it's not divisible by 2. However, it's divisible by the next prime number, which is 3. We get 5, 5, 1. So 15 is 3 times 5. And 36 is basically 2 to the power of 2 times 3 to the power of 2, right? Because 36, if you want to do it mentally, 36 is 4 times 9, and 4 is 2 to the power of 2, and 9 is 3 to the power of 3. So don't be surprised if I do it fast. I don't necessarily use this method. You know, when I want to do it mentally, I don't always use this method. So that's how people get it fast. Don't be surprised. If you're good with multiplication, you can do that as well. Now, look here. This is a bit interesting because we got 3 factors. We have 2, 3, 3, and 5. So the factors are 2, 3, and 5. I told you include all the common and non-common, which is 5 here, right? You have to write all of them. Now we go for the highest power. Well, 2 is only shown up here, so we have no choice. Whatever power it has, we have to copy it here. 3, however, we have a choice between 1 and 2, and I told you go for the highest. And 5, again, no choice because it has only shown up here and the power is 1. And if you carry out this calculation, you see the answer is 4 times 5, that is 20, times 9, that is 180. Right? So that's quite a big number. So meaning which if you wanted to do it the old way, you have to list all the multiples of 15 and 36 until you reach 180. And that's the lowest common multiple. Now, the types of question that they can ask you in IGCSE exam is that they directly ask you to find the HCF or LCM of 2 or 3 numbers. However, the LCM is useful when we want to work with fraction numbers, right? The fractional numbers, when we want to carry out arithmetic operations such as addition and subtraction, when you want to find the common denominator, well, the LCM comes handy and helps us. So there is another topic that we're gonna use LCM. So I think for numbers, we are done here. We talked about irrational numbers as well. And that's it. That's it for topic 1. And I hope you enjoyed the video, guys. Stay safe and see you in next class. Thank you.